Hello to our 8th graders. This is Bronco, and again, welcome back to the Flight Adventure Deck. Listen, as you all know, we are providing our field trips either via travel or via remote. And as far as the remote field trips, what I want to do right now is just go ahead and provide you a glimpse of just part of the instruction. And that would be about aircraft engines, which is going to be part of remote curriculum and also the travel curriculum. The content is going to be the same in either one. However, the delivery will be different. What it will do, though, is replicate as much as possible what you would actually see here on a live field trip at the Flight Adventure Deck. Although I would look forward to serving y'all at the Flight Adventure Deck sometime here in the future. Maybe when COVID-19 lifts, y'all will be able to go ahead and come back out here again, and then we can go ahead and provide this to you. So enjoy the video. This is the turbine engine, which is part of the 8th grade activities. This engine is used in jet aircraft, such as the AV-8 Harrier, the F-4 Phantom, the F-14 Tomcat, the F-18 Hornet. And those are just some examples. What we'll do now, though, is go over each of the phases of the turbine engine.
In the turbine engine, all 5 phases are all occurring at the same time, which is not the same as the piston engine. In the piston engine, each of the stroke cycles are all occurring at different times, as you see here. You'll record the 5 phases of the turbine engine.
First phase that you see on the left is intake. On the first phase of the intake phase, you see the white lights right there. What happens is that air is pulled into the turbojet's intake by the action of the compressor turbines. After startup, the compressor is driven by the power turbines through a connecting shaft.
Record the intake phase as you see here.
One question that I'd like to ask our students is, do they want to be standing in front of the intake? And what would happen? What would happen is we would want them to say that you will get sucked in. And this engine is powerful enough that it can suck in all the air of a house just within seconds. If you read right here, you can see that it states that air is drawn in and compressed. This right here is the turbine engine. It's the Westinghouse J34 turbojet engine. We just went over the intake. This right here is the compressor section. The next phase is the compression section, which you can see the compression section right here. And you can also see it right here. We'll now go and push the blue button, which I have our students do. And you can see the white lights here and also the blue lights. Air is drawn in and compressed. And then fuel is mixed with high pressure air. The air is pressurized through the multiple stages of the compressor section. Those are the multiple stages of the compressor section. And then the high pressure air, it's then mixed with fuel sprayed from the injectors, forming a fine fuel air mist.
Record the compression phase as you see here.
This is the compressor section where you see all those fan blades. What happened is that when air goes inside, it will then start to speed up. When it speeds up, then you will now get high pressure air, and then the temperature will also increase. This is another example here of Boyle's law, where the pressure will increase and then the volume will decrease. The next phase is the combustion phase, which you can see right here with the orange, red, and also yellow and purple colored lights. Fuel-air mixture is burned. What happens is the fuel-air mixture is ignited and burned in the combustion chamber, and it produces a high velocity gas.
Record the combustion phase, as you see here.
And in the combustion phase, fuel-air mixture is burned. What you've seen so far was the fuel, which is stored energy, that is potential energy. When it goes into the engine and into the compressor section, and then when it now ends up in the combustion phase, you've now gone from potential energy to thermal energy. Thermal energy right here in the combustion section. What we'll do now is go ahead and push the button, which I have the speed, and you can see the lights that you saw earlier. Earlier, I showed you the compressor section, which is right here. And then right here is where combustion is going to take place, which you saw on the schematic up above. Next is the power phase. I'll go ahead and push the red button, which we have our students do. And right here, you can see the power turbines. High pressure gases are turning the power turbine, which you can see right here. What happened is that the power turbine, it extracts just enough energy from the gas to drive the compressor section.
Record the power phase, as you see here.
You've gone from potential energy or stored energy with the fuel to thermal energy, heat energy in the combustion chamber. And then now you've gone to mechanical energy, which is now producing work right here in the power turbine in the power phase. Right here you can see the power turbine right here, in which you've got mechanical energy because you've got movement of the power turbine. The last phase is the exhaust phase, which you can see right here. What happens is that the high velocity gases, they accelerate out of the exhaust. That's the exhaust. We'll go ahead and push the button, and that's what we'll have the students do. And you can see the exhaust with the lights, the red lights. What happens is that the rest of the energy in the gas, it will provide thrust by expanding at high velocity through the open jet nozzle. In some engines, this can also be increased when you burn extra fuel in the exhaust through what is called an afterburner.
Record the exhaust phase, as you see here.
One question for the students is to go ahead and explain Newton's third law as related to this. What's going to go backwards and what's going to go forward? What is evidence that you see Newton's third law? Go and post your answer on Google Jamboard, Pear Deck, or whatever other means I'm asking you to do that on. Okay, the answer then should be Newton's third law is proven when you see the exhaust going backwards, which means that the thrust enables the aircraft to go forward. That's Newton's third law. What you see here is the tailpipe of the aircraft. And now over here you see the power turbine. And on the tailpipe of the aircraft, that's where the high velocity gases will accelerate out the exhaust, and that is the fifth and final phase of a turbine engine. And as far as proof of Newton's third law, when you see the exhaust going backwards, that's evidence of thrust, which enables the airplane to go forward. This is the turbine engine. Right here is the intake, or the intake phase. As you saw in the other turbine engine, here are the fan blades, which show the multiple stages of the compressor section. Then what you have right here is the combustion chamber, the combustion phase. Right here is the power phase, which you see the power turbines. And finally, the exhaust phase. Let's go ahead and turn on this engine. Now you see everything turning. Air goes in. Airflow goes in here. Air is now compressed. It's going to be an example of Boyle's law. Pressure increases and the volume will decrease. Pressure will increase and the temperature will also increase. And because the airflow is moving faster, that also creates a temperature increase. And right here is the combustion chamber. And remember, what we mentioned was that your fuel is stored energy or potential energy. It's now been converted to thermal energy here in the combustion chamber. Thermal energy is heat energy. And what happens is that the air molecules are all now bouncing off each other, also creating kinetic energy and additional heat. It's now converted to mechanical energy with the power turbines. Mechanical energy is creating work. And then you see the exhaust coming out of the tailpipe. And then I'll ask the students to explain Newton's third law is related to the exhaust. What they should say is that the exhaust of the jet is going backwards, which shows that the thrust enables the airplane to go forward. Newton's third law is for every action there's an equal and opposite reaction. And since they're able to observe the exhaust going backwards and the airplane going forward, that's evidence of Newton's third law. Okay, thanks for watching the video. And I'd like to go ahead and say farewell for now. However, we definitely would look forward to serving you at the Flight Adventure Deck sometime here in the future. So ciao, adios, pa'alam, and hanggang sa muli.